perpendicular lines. Unlike parallel lines, perpendicular lines are going to cross, but they cross in a very particular manner. They cross at 90 degrees. Okay, so if two lines cross at 90 degrees, they are considered perpendicular. Okay, so most of lines will cross, in fact, only if you have parallel lines, which we saw in the previous example will they not. But most lines will cross at some point, and they're going to cross at some point somewhere. Okay, you'll notice that these are crossing right there. Okay, so those ones do cross. But if the slopes of the lines, if the lines cross at 90 degrees, they are perpendicular to each other. Okay, so again, that's a little box there. We remember that from both measurement as well as trigonometry. That represents 90 degrees. Now, what happens with the slopes? Okay, so we have three lines here. We have line AB, CD, and EF. Okay, so those are the three lines that we have here. And so I'm going to put that in there. We're going to start with AB. Line AB, what is the slope of line AB? Well, I'm going to draw out my little triangle here. Just like that. Now, we are starting here, so we're actually going to have a negative here, but let's look at a run first. 1, 2, 3, 4, 5, 6, 7. Again, it's rise over run, and the run is 7, and the rise is 1, 2, 3, 4, 5, negative 5. Okay, we're going down 5, so we have a rise of negative 5. So that's AB. Next, let's take a look at CD, and I'm going to draw in the little triangle here again, as such. There we go. And so CD, it looks like it might be parallel to the first line. We again are going down, so 1, 2, 3, 4, 5, negative 5, that is the same. And 1, 2, 3, 4, 5, 6, 7. Negative 5 over 7, these are parallel lines. Okay, so AB and CD are parallel lines, meaning that they will never cross as long as they go. We have this other line right here, okay, EF, and EF is showing is perpendicular. Okay, and let's take a look at the slope of EF. And so I'm going to draw again the lines, the little triangle in. There we go. So EF, our slope is again rise over run, and this time now we're going up, so it's going to be positive. 1, 2, 3, 4, 5, 6, 7, and run is 1, 2, 3, 4, 5. Okay, this is perpendicular to AB and CD. Okay, it is perpendicular to those lines based on what we see here. But what do we notice about the slopes? These ones are negative 5 over 7. This one is 7 over 5, positive. These are negative, this is positive. Okay, so what we're going to see is that in fact a perpendicular line is what we call a negative reciprocal of its other line. Okay, and that's what it's saying right here. Okay, so when the slopes are what we call negative reciprocals of each other, the lines are perpendicular. Okay, the lines are perpendicular. I'm just going to go back to this side here. Negative reciprocal means that the two numbers are flipped. Okay, remember reciprocal. When we're dividing by fractions, remember we multiply by the reciprocal, we flip it. So we flip the numbers. Okay, the 7 was on the bottom, now it's on top, and we're going to change the sign of it. So if this one is negative, this one will be positive. If this was positive, that'd be negative. Okay, we just switch the sign. We just give it the opposite sign, and that means that in fact they are perpendicular. Okay, so looking at the slopes, this tells us that they are perpendicular. So what we can say is we can say therefore, and I'm going to use a little bit of shorthand here, line CD and AB are, and now for perpendicular we can use an upside down T, that represents perpendicular, are perpendicular to, and I forgot to put the little line segment on here, to line segment EF. Okay, and that's what we can say. CD and AB are perpendicular to EF based on their slopes. Okay, based on their slopes. Now again, important to remember, they must be negative reciprocals.